Hello and welcome to an Ionis Cloud workshop on WordPress scaling. So let's dive right in and examine some ways that you can scale a WordPress site. Some of these ways on scaling a WordPress site include breaking out the database functions or hosting the database function on its own server instance. This increases the performance of the database by having it on its own instance. Some other ways are increasing the number of users or pages that can be loaded by implementing a load balancer on the front end. Other ways are implementing web and database caching layers. We can also move static content like images and static pages to S3. And another way is implementing a CDN. Today we're going to look at the first two items, breaking out the database functions and implementing a load balancer. Before we get started, we just want to go over the basics of how this website is set up. For our purposes, we are using a WordPress site, and it's using one of the most common WordPress themes and plugins that are out there today. Our site's mostly static content, so it lends itself pretty well to a load-balanced implementation. Your site is going to be different, though. It may not lend itself to a load-balanced configuration. So it's important to come up with a testing and load testing plan that is going to show how your site is going to react with a load balance configuration. Some of the other things to take under consideration is that things like file system replication and WordPress replication are not covered in this implementation setup. So doing those configurations are something you are going to need to look at before you implement this. So, all of that being said, what were the performance results of the load balance configuration for us? Well, we built out some real-world browser-based load testing scripts using a load testing site called loadster.io. Using those same real-world scripts on a single WordPress server with 6 core and 6 gig of RAM, we were able to serve approximately 13,000 pages in a 5-minute period. Using those same 6 cores and 6 gig of RAM spread out in a load balanced implementation, the results were approximately 57,000 pages. So let's see how we built out this load balanced environment. We're going to get started with this build by going to dcd.ionis.com. If you haven't already, click on the Start Free Trial button to get your 30-day free trial. When you log in, you'll receive the list of your data centers that you've created, or you create a new data center, give it a name, and choose the region that you want to create your data center in. For this build, we are going to be using a NAT gateway, which will provide outbound access to the internet for servers behind it in a private IP range. The NAT gateway and load balancer also require static IP addresses to be reserved through the IP manager located at the top. Please click on the IP manager, click the plus sign to reserve the IP address, then go to the Public IPs drop-down and select the IP address to be used for the NAT gateway. In order to provision the NAT gateway properly, we will be using a temp server to create that internal private network we talked about previously. We will create that by dragging the plus sign to the NAT gateway. We will also be creating the internal network by clicking Add IP and entering the IP address we would like for the network. Here we are going to be using 192.168.10.1. Now that we have that, we'll click Provision Changes and Provision Now. This process can take a couple minutes.
Once the NAT gateway provisioning has been completed, we need to create an outbound NAT gateway rule. We do this by clicking on the NAT gateway and then clicking on the NAT rules. Here we create the NAT rule. We give the NAT rule a name, and then we need to select the public IP we want the NAT rule to use. We use the previously reserved IP address. We also enter the subnet that we want to use. That's our private network that we entered earlier, the 192.168.10.0. And then the target address. Here we're going to use a wildcard, or 0.0.0.0/0, which represents everything. Now we're also going to build out our database server. Here we're going to drag out a server element and connect it to the private network of 192.168.10.0. We'll give this element a name. We're also going to give this an IP address. And again, this is going to be a private IP address. And we will give this a private IP of 192.168.10.20. We're also going to uncheck the box that will give it a gateway IP address, as we're going to set this later. Next, we're going to add the storage. And then we're going to select the image we want to use. In this case, we are going to use the Ionis provided Ubuntu LTS image. We'll set a root password as well. And then we're going to go to the Ionis Labs site and copy the cloud init script we're going to use to build out the MySQL database server. You'll see it here on the database deploy. We'll copy this and go back to our DCD environment and paste it into the cloud init user data section. Remember to set the DB name, user, and password in the parameters section of the script for the configuration that you want. Then click Provision Changes to start building out that database server. Actually, prior to provisioning these changes, I'm going to remove the temp server since we no longer need it within our configuration, and then click Provision Now to provision these changes. Once provisioning is completed, I'm going to right-click on the DB1 instance and go to Console so I can watch the build process on the console of the server itself. Here you will actually see the cloud init script do its initial build of the MySQL server as we laid out in the build script. This process can take several minutes to complete. So since we want to watch this process as it's moving along, we're going to log in as root and the password we previously set. In order to watch the installation as it moves along, we're going to tail the cloud init output file. You can see that command here. Once it's completed, we will see that the cloud init output file displays the OK finished execute cloud user final scripts. That tells us that everything's completed. Now the DB server is ready for use. So now that our database server is ready, we're going to build our front-end WordPress server instances. We're going to start by dragging a server instance out to the grid. Then the next thing that we're going to do is drag a load balancer instance out. We have two types of load balancers, an application load balancer and a network load balancer. I'm going to use a network load balancer in this case, where I'm going to have an outside IP address and an inside. Outside connection is going to my internet icon, and the inside is going to my private network. I'm going to connect my new WordPress front-end instance to that inside network along with the load balancer, and give my WordPress front-end instance a name, WP1, and I'm going to set it to a private IP address, in this case 192.168.10.10, and uncheck that gateway IP will be assigned. Now I'm going to add my storage and give that storage a name. And I'm going to choose my image. Again, this is going to be an Ubuntu image. Set my root password. And next I'm going to copy the cloud init data from the Ionis Labs site, which will automatically build out and set the IP address of this WordPress instance. That's under the WordPress deploy section. And again, take note of the variables that need to be set here: the DB name, user, and password, and in this case the DB host IP address, which we previously set to 192.168.10.20. I'm going to go to that cloud init configuration and paste that script in here. Again, taking note of those variables. And I'll click provision. Here you can see I actually encountered an error because I didn't assign the static IP address to the load balancer. So I'm going to click OK and correct that mistake by clicking on my load balancer and going to the IP address section and going to that assigned IP address that I did previously, clicking on it, and then clicking provision changes. I'll click provision now, and that will go through without that error. Once the load balancer has been created, we need to give it an IP address on our internal network. We do this by clicking on the load balancer and then clicking on the private IP tab. Once that section is up, we're going to click on Add IP and give it an IP address in our 192.168.10 network. We'll then also remove the IP address that was auto-assigned to it, and we'll provision the changes. And then once the internal IP address has been assigned, we need a forwarding rule to forward traffic to our front-end web server. We do that by clicking on the load balancer again and clicking forwarding rules, giving that forwarding rule a name, adding the external IP address as the listener IP and 80 for the port, and then for the target IP we're going to select our internal web server that we just built, and again using that port 80 for the IP address. Once we've added that target, we're going to provision the changes again. The front-end WordPress server should be up and running now and is listening on port 80 on the internal network. The load balancer should also be forwarding traffic to that internal server. We're going to try to go to that IP address of the external load balancer to see if we get the WordPress site, which we do. We'll finish the WordPress site setup here. Finally, for my setup, I'm going to log into the Ionis Domains and Hosting and point my ionislabs.org domain to the IP address of the load balancer so that I can restore my ionislabs.org site to this WordPress instance for load testing. Then I restore my site to the WordPress server running behind the load balancer, and as you can see here, it is now running off of that WordPress instance. Now that I have that WordPress instance running off of that server with the separated database server, and I like the configuration of the site, I'm going to create a snapshot of this instance by right-clicking on the hard drive of the WordPress instance and going to create snapshot. I'll then give this snapshot a name so that I can reference it later. The snapshot will take a couple minutes to create, and I'll watch it via the image manager. Here you can see the snapshot is still being created. Now that this snapshot has been created, I'm going to add an additional front-end web server to my load balancer. I'm going to drag another server out to the DCD grid, connect it to the internal network. I will then give this instance another IP address, uncheck the gateway IP, add storage to this instance, and when I go to select the image, I will choose snapshots and find the WordPress image snapshot that I previously created. I will now provision this instance and wait for this instance to come up. Now that my second WordPress server is up and running, I'm going to add it to the load balancer by clicking the load balancer and going to forwarding rules. I'm going to scroll down and go to add target. Here I'm going to go to the drop down and select the IP address of the server. Also, it's listening on port 80. I'm also going to disable the health check settings for testing purposes. Now that that's set, I'm going to provision my changes. Now that both servers are on the load balancer, I'm going to go back to the web page, refreshing it, and make sure that the page continues to load. As you can see here, it loads just fine. As a final test, I'm going to go back to my DCD and power off the first WordPress server and make sure that the page continues to load from there. After powering off that server, I'll go back to the ionislabs.org page and continue to browse. As you can see, the pages still load, showing that it's still connecting to the one remaining server and loading the pages.
And that's how we scale a WordPress site using a load balancer. For more information, please visit these links. And once again, thanks for joining us.